Hello, Mr. Stone here. Today we're going to practice working with units. Now, let's say we need to convert from 2.52 meters to centimeters. Very easy, you say. I'm just going to multiply 2.52 times 100, and there I go. I've got 252 centimeters all done. Yes, in this particular case that works just fine and dandy. However, what would be more useful would be a structure that we could use to convert not just simple conversions such as this, but also more complex conversions. So for example, if we preview a little bit ahead, 2.52 meters to kilometers. Wow, that is right most of the time maybe, but what can we do so that we can have some sort of structure that we can go back to that will help us in this case and in most any case with units that you may find? Let's do this. If I've got 2.52 meters, and I know that my end result I want to be something with centimeters, I can think of it as multiplying by something that will cancel out the units. So this is meters, that is an M. I want to have meters on the bottom down there because if you have meters in the denominator and the numerator, they will cancel each other out. Centimeters is what I want, so I want to leave that in the numerator. I know that there are 100 centimeters for every 1 meter. If I were to multiply these out, then the meters would cancel, and I'm left with 2.52 times 100, which is simply 252 centimeters. There we go, that is solved. All right. You may say, oh, I don't need all that for that. That's too much work. No. That structure, if you practice it and you use it all the time, that will help you out when you get to more complex stuff, such as this. So I see this mistake made quite often. Do I multiply? Do I divide? Which one do I do? Well, if you're going from 2.52 meters and you know that you want to end up with something kilometers, set it up as so. You know you need to multiply it by, what do you want? I want kilometers. Kilometers are going to go up top, meters are going to go at the bottom so that they cancel each other out. I know that for every 1 kilometer there are 1,000 meters. Therefore, I can multiply these straight across. You can assume that there is a 1 beneath there because there's a 1 quite technically below just about any number that we've got. It's a terrible fraction, really shouldn't exist, but it does for purposes of our working. Multiply straight across. 2.52 times 1 gives us 2.52 over 1 times 1,000, 2.52 over 1,000. The meters cancel out, so the unit that I'm left with is kilometers. You can take what you've got if you want to put it into a pure decimal form, put that into your handy-dandy calculator, and you end up with 0.00252 kilometers. There you go. You can be confident with this because you know that your units are placed here appropriately. You're not confused. Do I divide? Do I multiply? You're set. Okay, that's the power of this structure. Let's take it one step further. 2.52 meters, I want to go to feet. All right, and I'm going, if I were to do this, I would say, I can't remember my conversion between meters and feet. Meters and feet. There we go. I can't remember my exact proportion for meters to feet. So what I do know is that there are 2.54 centimeters per inch, and I know that there are 12 inches per foot. Using those, I can make a little bit more of a longer chain to get to my correct answer. So I'm going to start with 2.52 meters. Make sure you've got your unit there, and I know that I'm going to end up with something feet. Well, let's start off. I've got centimeters up here, and I know I can do meters to centimeters, so I'm going to multiply this by, I'm going to have centimeters on top, meters on the bottom. I know there's 100 centimeters for every 1 meter. My meters then cancel. I multiply that, I'm now in centimeters, I can go to inches. So I want to be in inches, so that's going to be on top, and centimeters will be on the bottom. I know that for every 1 inch I have 2.54 centimeters. The centimeters then cancel out. And now that I'm in inches, I can go to feet. So I know that for every, I want feet to be in the numerator, and for every 1 foot, I've got 12 inches. Remember that when you multiply by 1 over, like 2.54 or 1 over 12, you're really just dividing by 12. It's the reciprocal. So you're left with 2.52 times 100, right here, then divide by 2.54. This is divide by 2.54. And then here, you're dividing by 12. And you end up with 8.27 feet. All the units take care of themselves. That's what makes this structure so powerful and helpful. You can also use it when you're working between units. So 55 miles per hour, you drive for 6.5 hours. How far do you go? Well, it helps if you think of 55 miles per hour is 55 miles per hour. This is a ratio. This is another example of how ratios are all around us in our world every day. 55 miles per hour, you can think of the dividing line there as per. So 55 miles per hour, you are driving for 6.5 hours. So you can put hours up top, and really there's no unit for that on the bottom, so that you just have 1 below. The hours cancel, so you're left with 55 times 6.5, which yields you 357.5 miles. That's it. Then you are set. Again, the units take care of themselves. Lastly, if you have 340 miles, how fast would you have to go to make that distance in 7 hours? If you use the same ratio as we did a moment ago, miles per hour, remember the line is per, 340 miles in 7 hours. Simplify this and you have your answer. That's it. That's what's so powerful about this. You end up with 48.57 miles for 1 hour, or simply put 48.57 miles per hour. Practice with this. We will do some work with that in class. Bring in the questions that you have, and I guarantee you, if you are using this method, I think you will find working between units so much easier and so much less stress for you to do. All right, have fun and have a great day.